So as I said in the morning, right, I mean, I have fallen on hard times. I submitted a talk and it didn't get selected. So I thought, let me at least try to submit a lightning talk, right? So this presentation was done by my colleague Fabrizio at PGConf Ottawa in the last PGCon that happened there, and we were hoping to do a longer session, but yeah. So briefly, what is Timescale DB, right? It's a open source relational database that specializes in time series and events data. You would argue that every data is time series. I mean, every database has a time series component in it, right? So I would even dare to say that this could apply to all the use cases out there. It's packaged as an extension on top of Postgres. And again, this speaks volumes about the architecture of Postgres, right? I mean, here, you have such extensive functionality that you can provide by extending Postgres via extensions, right? So again, that speaks volumes about the architecture of Postgres. And since we deal with time series data, we have a host of time-specific functions, aggregates, and you name it. Timescale has been tuned for very large ingest rates, so I won't get into that. In terms of terminology, we have what we call as hypertables in Timescale, and they are nothing but normal tables which are partitioned automatically by Timescale DB. We all know that with a large data set, handling it becomes a headache, right? And eventually, most of us start looking at partitioning. But trying to do it yourself, or trying to come up with a strategy, it takes a lot of cycles. What you can get here is automatic partitioning if you use Timescale. So the topic is about materialized views, and what we have done with it, we call it as continuous aggregates. So here's a typical traditional PostgreSQL view, right? A view is nothing but a name that you provide to a query. You might have a very complex query which you need to run again and again, and obviously you don't want to type it every time, right? So PostgreSQL provides views, so you can just say create view and specify the query, and whenever you execute the view, that underlying query is executed basically, right? But the problem with regular views is they execute every time you run the view, right? So if it's a very complex query, if it is data and CPU intensive, it's going to take a lot of time. So the solution that Postgres came up with is materialized views. So essentially, now what you do is you run the same query, but whatever is the result of that query at that point in time, you save it into a materialized view. And since essentially a materialized view is a regular Postgres table, you can add indexes on top of it and then query it later. Here's an example. But again, materialized views also have an issue, right? As I mentioned some time ago, it's a point in time executed output that you store in that materialized view. But if you have intensive data operations in your table, that mat view gets out of date very quickly, right? So what do you do there? Obviously, we have refresh materialized view in Postgres. And what that does is it basically truncates the old materialized view. It reruns the entire query at the current point in time and then replaces the old view with the new, right? But again, this works only to a certain level. What do you have, frequent data changes? What do you have, like, maybe you're adding like millions of rows in one day. How do you deal with that? So again, the refresh materialized view cannot be run so frequently. So we at Timescale tried to, find a solution to this, and we call them as CAGs, continuous aggregates. What are continuous aggregates? They are basically materialized views, but they are continuously and automatically incrementally updated. So The idea here is to keep a track of the new data that's entering into your source table and keep on additionally materializing that, right? The way we do that is we track a watermark, which is the point in time up to which we have done the materialization earlier, right? And when we want to refresh, we know exactly at what point in time should we refresh from, right? And obviously, when we do the refresh, the watermark gets updated to the latest value. So here's a regular hypertable which contains your partition data, and time is moving. What you can do is you can create a policy in Timescale wherein you can say refresh my CAG every half an hour or every 1 hour or whatever granularity you want to choose. So when we run the refresh, and as I said, you can specify a policy for that. It will automatically find out the watermark and only refresh the data that lies beyond that watermark. Okay. So you might ask a question, this is fine and dandy, if you only have append only kind of a workload. But there are cases where you might want to backfill. Okay, I'm running out of time. Sorry. So we even have a solution for that. What we do is basically we maintain an invalidation log. So whenever data gets backfilled, we track that inside an invalidation log. And at the time of refresh, we not only look at the latest data, but we also look at the data that got invalidated and refresh that as well. Yeah. And obviously, we also provide real-time aggregates. So what we do is, for the data up to the watermark, we run the query on the materialized view, and we do a union with the latest data which is following the watermark. So this ways you can get real-time aggregates working as well. Okay, so you can also then do fantastic things like build a hierarchical CAG. So it's an aggregate over a continuous aggregate, right? So it can look like this. You have your stocks table, and you have your CAGs based on day, minute, minutes, hours, days, months, and basically you can just play around with this. The good thing is, you don't even need to maintain the actual data in the real hypertable. You can choose to delete it, but because you have materialized it, you can still query that using the hierarchical CAGs. Okay, sorry. Thank you. Thanks for taking time.